presentation will cover Metso green technology for pulp production. My name is Eva Engelfeldt and I work as a sales manager within Metso. I am mainly involved in capital sales projects for chemical pulping lines located in Central Europe, India or China. I am located in Sundsvall, Sweden. I will shortly present Metso green technology for fiber lines, that is the production of bleached hardwood softwood kraft pulp after the digester up to bleached storage tower. I will put emphasis on the difference between filters and presses, as one of our threats to environment-friendly fiber lines are low-cost filters based on old technology. The washers are the key equipment throughout the fiber line, and the Metso twin roll press is our key product. This picture shows our latest generation of our twin roll press, that is a twin roll press evolution, which is being installed in ITC Bhadrachalam for fiber line 2. Metso has been successful in India during the recent years. This picture shows some of our installations in India. And most of these fiber lines meets the toughest environment requirements anywhere in the world. In this picture we can see water discharges from bleach plant with different washing equipment. Earlier, with older type of vacuum filters, the water discharge to environment or effluent treatment plant was between 50 and 100 cubic meters per ton of pulp. With more modern filters, the discharge volume is reduced to around 25 cubic meters per ton of pulp. With presses as the washing equipment in the bleach plant, it is possible to reach lower than 10 cubic meters, even with special measures down to 5-6 cubic meters. As change from modern filter-based bleach plant to a press-based bleach plant will have a big impact on the operation costs as shown here. Several crores can be saved per year only on operation costs when reducing the effluent discharges. This is an example of a modern bleach plant configuration with filters. The usage of fresh water is to the last D-stage washer, the last alkaline stage washer, and to the last post-oxygen washer. The fresh water needed is then around 28 cubic meters per ton of pulp, and the water discharge to effluent treatment around 20 cubic meters per ton of pulp. Here is a Metso reference as an example for the previous filter-based bleach plant. The mill is in Thailand, Phoenix Pulp and Paper, and the effluent discharge to effluent treatment is around 22 cubic meters per ton of pulp. Here is an example of a press-based bleach plant. Now the freshwater usage for D1, EOP and post-oxygen washer is around 13 cubic meter per ton of pulp instead of 28 cubic meter with filters as shown before. Also the discharge volume with press solution is around 10 cubic meter compared to 20 cubic meters with filters. In, for example, Tamil Nadu, the chemical bagasse pulp line there, they have a similar bleaching plant concept as shown here, and there we have a water consumption of around 15 cubic meter per ton of pulp. Let us jump into the other effluent parameters. Today the trend is to reduce the load towards the environment. One factor which all the governments around the world are looking at is the AOX amount in the effluent waters. If we want to go to low AOX, still using some chlorine chemical, such as chlorine dioxide, the key is to decrease the kappa number to the first bleaching stage containing chlorine chemicals. With an effective ozone stage as the first stage after the oxygen stage, it is possible to reduce the kappa into a D stage to 5 to 7. And then the results will be really low AOX level from the bleach plant. Metso is the leader in ozone technology in bleach plants with an with a unique design. Metso C-Track is a high consistency bleaching stage. High consistency enables the best delignification efficiency on the market and the best utilization of the ozone chemical for delignification. The system is shown here in a picture with a press to press the consistency up to 40%, a reactor with a 1-minute retention time, and a small alkaline stage to dissolute the lignin from the fibers. This is an example of a reference of an ozone-based bleach plant in Portugal. The effluent volume is on a really low level, 4 to 5 cubic meter, as they are recirculating all the alkaline filtrate from ozone stage to post-oxygen washer. Metso will soon start up an ozone reference in China this year, end of this year. It's the Ojinantong, and they will use Metso presses and C-Track technology in their mill. Capacity will be around 1,600 tons per day. ITC Badr Chalam has been running since 2007 or 2008 with ozone bleaching in both fiber lines. Metso has delivered over 1,300 presses during the last 60 years' time. This machine is the key to low water discharge fiber lines and also for low use of fresh water, then enabling low operation costs not only from effluent point of view but also from bleaching chemical cost point of view. This picture shows our key designer and production head in our workshop with the largest press we have built. It's a TRPE 2084, and this press is delivered to South America, and the capacity will be around 4,700 tons per day. I will briefly show you some figures on the operation cost of fiber lines with presses and with modern filters. This table shows us our estimations on the unit cost for utilities and effluent. Based on these unit costs, we have estimated the consumption numbers for filters and presses. As you can see, most of the numbers are clearly lower for presses. When calculating all the previous numbers, we can conclude that for a 200,000 tons per year mill, the annual operating costs savings are considerable. In this case, over 15 crore. Here we have estimated the operation costs when the washers are not operating at design parameters, which are normally 12% for a filter and 30% for the presses. If we operate on a 2% unit lower outlet consistency than design, that is 10% for the filters and 28% for the presses, we can see a much bigger impact on operation costs for the filter solution than for the press solution. So with filters, the operation costs will go up with 4 crore, whereas when having the same decrease in outlet consistency for presses, the operating costs increase is less than half of that. This means that even in conditions outside the balance, the press will work in a more stable way than the filters, contributing to a better overall mill performance. I will now show the results of a detailed investigation we have made comparing the total investment cost for a filter stage versus a press stage. The base for comparison is shown in this slide, and the difference in investment cost is less than 10% for the filter stage. We should then bear in mind that one press stage equals to approximately 1.5 filter stages in performance point of view. The amount of steel required for the filter stage is significantly higher looking at the total installation. Our message is that it is better to invest in technology than in steel. We need to be careful with our common resources, and that is what we call sustainability. This shows the basis for the electrical instrumentation and automation comparison for the two cases. And here we can see the layout difference between the press and filter stage, and the auxiliaries required, the piping and so on around it. And you can also see the scope what we have included in the comparison. So from total investment point of view, it's not much difference between a press stage and a filter stage. Press stage is around 10% more expensive. For greenfield pulp mills, we promote press-based fiber lines. For upgrades of old fiber lines with filter technology, our philosophy is that the most efficient washers shall be utilized where washing is most important, and that is in front of the oxygen stage and in front of the bleach plant. So, put the presentation in a nutshell. The environmental limits will not be looser, quite the opposite. The availability of water will be controlled by the authorities and also by the operational costs. Metso can help to manage the new situations now and in the future by supplying optimal solutions for fiber lines for each customer and conditions. By utilizing and optimizing the raw material in every phase of a project, we are proud to have sustainable solutions for the future. Thank you for your attention, ladies and gentlemen.
Redan klart, va?
Mr. Thomas, Mr. Thomas, please show your screen. Yeah, now we can see it. Please open the presentation. Yeah, Mr. Thomas, please open the presentation.
Hello, Thomas Sandstedt here.
Yeah, Mr. Thomas, can you hear us?
I can hear you.
Can you open your presentation on the screen, on your laptop screen?
The presentation will be made by Otto Lindeberg, and I will just assist for questions after the presentation.
Okay. So I would request then Mr. Otto Lindberg to kindly start his presentation. I think he's from Palpai.
That's correct.
Good afternoon, Mr. Otto. Can you hear us?
Yes, I can hear you.
Yeah. Can you open? Yeah. Your presentation is there. I would request you to kindly start the presentation, please. And after this presentation, we will take the question answers both for Metso as well as Palpai after the end of Mr. Otto's presentation. Yeah, please. Over to Mr. Otto.
Okay. Ladies and gentlemen, I will talk about process optimization based on pulp strength properties predicted from online fiber and krill data. My name is Otto Lindeberg and my company is Extract Information AB. This is a joint presentation by Extract Information, Vaggeryd Cell, and Invensia and Palpai. And you have the contact information at the bottom of the slide in case you have questions afterwards. Please get in contact with us if there are questions. What I will talk about is a development project, and it has resulted that as a result, we now at Vaggeryd Cell can predict pulp strength properties online. The properties are Scott bond and tiered, tensile, and burst index. For this, we are using state-of-the-art technology, the Palpai pulp analyzer and the Extracti software. Having pulp strength properties online means that they are frequently available. There's no need to wait for lab data, for lab analysis. We have new strength values every 5 to 15 minutes, and as a result, there is also less man-hours required for lab work. Having online strength properties available, we can use these to run process closer to specifications because we make predicted values available in the DCS system. And we can also easily communicate the stable quality to the Vaggeryd Cell customers. The batch quality can be compiled for each order. The partners in this joint project is Palpai AB, which is an innovative measurement technology company focusing on online application and services in the pulp and paper industry, with the whole world as their market. Main products are the Palpai pulp analyzer, which has been used in this project, and the Scanchip chip analyzer. Extract Information AB has provided the software used and provides easy-to-use and powerful software and data analysis services for effective and advanced analysis of lab and process data to increase productivity and quality even in pulp, paper, and board production. Pulp company have their head office in Örnsköldsvik in Sweden, and they also have offices in Timrå and Västerås in Sweden, and they also have offices in Germany, Canada, and United States. The head office for Extract Information is in Norrköping. Customers using the PulpEye analyzer are shown on these slides. These are major pulp and paper companies, and I now highlight the companies that are also using the Extracteye software. The majority of these companies are using the Extracteye software for advanced applications, as shown in this presentation, to increase the value provided by the fiber data from PulpEye. Our industrial partner is Vaggeryd Cell. They are located about 35 kilometers south of Jönköping, which we have here, or 330 kilometers south of Stockholm. And they have about 180 kilometers to the port in Gothenburg. Vaggeryd Cell AB, their owner is ATA Holdings with 100% ownership. Production is softwood CTMP, and the annual capacity is 175,000 tons, with a net turnover of about $60 million US. It's an efficient mill with just 43 employees, and the shipment from the mill, 90% is exported, and the major end use is in board production, but also for printing and writing, tissue, and other grades. Vaggeryd Cell has incorporated the very latest technology to make Vaggeryd a leader in quality and efficiency. And besides technology, the excellent quality is also a result of using raw material from the outer parts of the tree with a large percentage of early wood with thin-walled slender fibers. Over the years, a number of improvement projects has been carried out, and this shows the areas for the latest improvements. You have in ship washing, impregnation, refining, heat recovery, and washing, and bleaching, and flash drying, and also in the baling line. The total cost for these improvement projects is approximately $65 million US, and of that about $13 million US has been used for improvements in the wastewater plant. All these investments have led to a significant production increase, which is about 150% since 1999. And this slide shows the yearly increase in production from 1999 to 2012, and the current production is about 3,200 tons per employee, which is quite a significant number. The fourth partner in this project is Inventia. This is a research institute owned by industry and government, and it performs commissioned research, exploratory research, often with governmental funding, and it's also there are also cluster research programs with several partners, and also bilateral single client projects. And Invensia work in close collaboration with other institutes, universities, and in EU-funded projects. Invensia has developed the krill sensor, which is an important measurement that is used in the prediction of the strength properties online. The krill measurement is based on comparison of two optically measured surface areas of fibers and using light absorption. The total area of fibers in krill, that is the fine material, the threads that you can see in this photograph, in this picture. This is measured with ultraviolet light, and the total area of the fibers only is measured with infrared light. The krill variable, CFR, is a concentration-independent ratio obtained when the fiber plus krill area measured with UV is divided by the fiber-only area measured with infrared light. No image analysis is required, and this makes the measurements extremely fast. The krill module is available in the PulpBy Pulp Analyzer. At the PaperTech conference in July this year, this PulpMix model was presented. The model is based on krill and fiber data measured with the PulpBy Pulp Analyzer. This PulpMix model was developed in a joint project between Invensia, PulpBy, and the Indian mill SPB. The project was partly sponsored by the Swedish Agency for Economic and Regional Growth. By using PulpMix models, as shown on the previous slide, it was concluded at the PaperTech conference that you can achieve better process control, you can reduce fiber costs by having the right mixture, you can reduce the overall energy consumption. It was also stated that models can be implemented for better process control, and I will continue along that line. Now I move on to talk about models for prediction of pulp strength properties online in Vaggeryd Cell. These models have been developed in cooperation by Vaggeryd Cell, PulpBy, and Extract Information, and the krill measurement developed by Invensia is an important part in these models. This is the PulpBy Analyzer at Vaggeryd Cell. It was installed during 2007, and investment in online fiber characterization has been an important part in the strive to be a leader in quality and efficiency at Vaggeryd Cell. The PulpBy Analyzer allows for faster and more accurate quality follow-up, and the disk filter standard deviation has decreased, and the pulp quality delivered to customers is defined from PulpBy data. In the Vaggeryd Cell mill, there are 3 sampling points, 1, 2, and 3, and we will focus on sample point 3, where measurements are made on the final pulp. The next slide will take some time to show. It's a large slide with a lot of data, so please. Oh, this time it showed very quickly. What is shown here is that we have during this year developed models for prediction of Scott bond. We have in the upper left-hand corner, tear index, upper right-hand corner, tensile index, lower left-hand corner, and burst index, lower right-hand corner. The green triangles are the samples that are used for creating the model and validating the model. And the blue lines are predictions made from the models that we have created. And you can see that we cover most of quite a substantial period of time here. The models were initially created based on just a few samples, and over the year more samples have been used for validation and refining of these models. And looking at these trends, the first impression is that all trends look very similar, and I have highlighted some samples to show that the values are on different levels for different properties. So if you compare the difference in properties between these two and these two, as an example. The reason for the similarity between the trends is that the variability in the properties are correlated to a large extent. Besides being able to predict properties, pulp properties with Extracti, you can also monitor the stability of the pulp, which is of course important. And this screenshot shows the Extracti software, how this monitoring application looks. What you have in the upper left hand in the top graph, top diagram, are all the reference samples that have been used that we want to compare future production to. And we want to follow the stability of a number of variables that you can measure with the pulp-by-pulp analyzer. And these are listed on the right-hand side. What you want to follow are the deviations in these variables compared to the reference data that you have, the reference that you have created. The deviations in this right-hand slide, they are listed, so we have the largest deviation on top and then smaller and smaller deviations. What you do with all these deviations is that you create a weighted sum of the deviations, and you plot these deviations in the bottom trend here and as a deviation index. This deviation index is very useful because it summarizes all the interesting variables from the pulp-by analyzer, and if this deviation index is straight and horizontal and below a reference line, it can be seen the reference level can be seen in this gap here. If this is horizontal and below the reference line, that means that the pulp samples are similar to the reference. You can also show trends for the individual variables that you are monitoring, and you can select another trend by just clicking on the bars here. So the way you use this is that you create this reference and then you use it to monitor new samples. And in this case, we have used the model from the reference model from the previous slide. What we can see here is that the blue dots, the new samples, they are outside the confidence ellipse for the reference samples. But we can also see that the deviation index is a straight line, although it's on a new level. We can also see on the right-hand side, we have a lot of red bars, meaning that there are a lot of variables that are deviating from the reference that we had created. And we can also see which variables are deviating the most, and we can plot the trends for the individual variables. So the largest deviation is plotted automatically when you have a new observation. And this deviation list here is shown for the current observation that is highlighted with this blue vertical line or the red square in this diagram. The blue and green colors here represent different grades, so you can handle different grades with this application and create reference relevant for each grade. So the important thing is that this deviation index is stable, horizontal, stable, and well, just looking at this, you can conclude that the fiber properties are stable. You don't have to look into the individual properties to start with. This is how the actual application look in Vaggeryd. The colors you see here they are producing a lot of different grades, so each color represents grade. So you have the production from end of September to middle of October represented in these graphs. You also have the same colors up here showing the pulp index, where you have the different samples, and you can see that you have clusters of pulp samples in different areas representing the different grades. You have the deviation index. On the bottom you have the reference line, and you can see that different grades, well, all the different grades are below or close, just slightly above the reference line. And on the right top hand graph you can see the deviations for the variables that are used in the model for the current observation, the one highlighted with the blue vertical line. And in the bottom right hand trend you can see the predictions for the tensile index for the different grades. I will now switch to this application to show you how it works online, live. So this is the slide that I showed you. We have the deviation index in the left hand, in the bottom graph, and then if I move from forward in the production from the red grade to the blue grade, we see that the other diagrams are updated, so now variable 4 is deviating quite a lot, and we move on. And now it's variable 2 that is deviating. And we have the trend for variable 2 plotted here. You also see how we move in this pulp type index plot here. So we have the current observation, yellow square moving. So when I move along here, we see that there are different variables that are deviating the most. So this is a very quick way to analyze, find out what has happened during production regarding the fiber properties. And you also have the predicted value shown in the trend here. Besides, you can also have additional trends that you want to look at. So it's a flexible software. You can create the displays that that makes sense to you. This slide shows the predictions online for this period for Scott bond, for tear index, for tensile index, and burst index. And once again, the trends for the four properties look very similar at first sight. But if you look at the encircled qualities, you can see that properties are on different levels for different grades. If you look at Scott bond for the black and red grades and compared to the predicted tear index for the black and red grades, we see that there are different levels. And the same is for predicted tensile for the red and blue grade here and for burst index. So though they look similar, the predictions are different for different grades. To summarize once again, the benefits with predicted strength properties, they are frequently available. There's no need to wait for lab. You have them every 5 to 15 minutes, and you don't need to spend as much work on lab work to get the strength data. You can use this to run process closer to specifications, since predicted values are transferred to the DCS system and can be used in control applications. And stable quality is easily communicated to customers. You have batch quality can be compiled for each order, so you can have a very detailed numbers for your production. To run the way it's used in process optimization is that, well, you have, if you can decrease the standard deviation. As an example, Vaggeryd has experienced that the disk filters Canadian standard freeness standard deviation has decreased, but now these online prediction strength properties can be used for process improving the process. And with smaller standard deviation, if you have the old target value, you can move the target value closer to specifications, and this gives you the potential savings. The software used in this case, Extracti, comes in two flavors. Both are used in Vaggeryd Cell. The one that I showed you in the live demonstration is the client version that's working on your desktop, and then you can work with data from different databases. In this example here in Vaggeryd Cell, we're working with data from the Pulpine database, but you can also use Extracti for data from the chip analyzer scan chip and process databases like MOPS, TIPS-Info, AspenTech, IP21, and OCPI. There are interfaces to these databases. You can also use Extracti as a service, and then you read data from databases and write calculated values back to the database. And this is the way it's used in Vaggeryd Cell to provide values that are transferred to the DCS system. To summarize the advantages of the Extracti software, as I've been trying to show you, is to monitor the stability of the pulp. One trend is all you need for the initial monitoring. The deviation index shows you the stability of the pulp. And this is an effective way to decide if pulp or process is on target. You can use it in morning meetings, and you can use it on return to shift. You can use it as a decision support. There's more frequent lab testing required if you have a pulp sample that is deviating. And you can think about which customer this product would be most suitable for. If you use it during mill trials, it shows the overall stability during the trial. And it can also be used to monitor the stability of the pulp analyzer itself for fault detection. And as I've shown you, you can use it to predict pulp and pulp properties, and it's also used for prediction of paper properties. And there are other uses also. So with this extract information, Vaggeryd, Invensia, and Pulpeye, thank you for your attention. And if you have questions, I will try to answer them. And if I can't answer the questions, please feel free to contact my co-authors. You have the contact information in the bottom of the slide. Thank you.
Thanks, Mr. Otto, for the wonderful presentation. Dear friends, a small announcement. Actually, there was some confusion in the name of Mr. Thomas, so we will have another presentation from Metso. Mr. Thomas, he will be presenting after we finish off the questions for Mr. Otto. So first, I would request everybody, so if you have any questions for Mr. Otto, to kindly write your questions in the question window. So after that, there would be a presentation from Mr. Thomas of Metso. Please. There is a question from Mr. Chiranjit Pathak. Did you study on any Indian mill?
No, not so far. This development work has been carried out at the Vaggeryd Cell mill. But Vaggeryd Cell provides pulp for Indian customers.
Question from Mr. Matthias Drotz. How much have Vaggeryd earned on this installation?
Sorry, I didn't quite get how much have
Vaggeryd earned on this installation?
That's not the question for me to answer. That is more for Thomas Sandstedt, my co-author from Vaggeryd Cell. But this has been a development project this year, so we are starting up the use of these online prediction models.
Any other question, please? If there are no other questions, then can we now I would request Mr. Thomas Grandfeld for the presentation. A brief about Mr. Thomas Grandfeld. He is the process engineer, technical sales, pulp and energy fiber processing unit, and he is also the adjunct professor from Professor of Chemical Engineering, Mechanical Pulping in Mid Sweden University. So I would request Mr. Thomas Grandfeld, first of all, apologies for this confusion, and I would request him for the presentation, sir.
Hello, can you hear me?
We can hear you, Thomas. Yes, we can hear you. Thank you.
Excellent. Well, thank you for giving me this opportunity. I will speak briefly about CTMP for board grades in India. So far we have not been that successful in CTMP installations in India, but you could hear, at least from the previous presentation, that Vaggeryd is selling CTMP for the Indian market. And Vaggeryd is, by the way, installation of Metso. So I will not be as specific as Eva was in her presentation. I will give you a more brief overview of CTMP, what that is. So here is a picture of me and my contact information. I've been working with CTMP for many, many years, and especially with hardwood CTMP. And I've also worked a lot with development. So some CTMP basics. What is CTMP? Well, it's a chemi-thermomechanical pulp where we use a mild chemical impregnation of the hardwood chips, and normally we use maybe 15 to 30 kilograms per ton of sodium hydroxide, which is the active chemical in this case. So it's not that much chemicals here in the impregnation stage. We then have a pressurized high consistency refining of the chips, and in some cases it's only one stage, and depending on raw material and end product it might be even 2 stages. And we can also have that at low consistency. We have screening and redirect refining normally. We have pulp washing in several stages depending on the end product and how clean the pulp should be. And of course, in order to limit the water consumption. In order to bleach the CTMP, we use peroxide bleaching, so we preserve the lignin content and brighten the pulp. Typical brightness levels are, I would say, 75 to 80 plus. In some cases we can bleach even higher. Typical charge here is 50 kilograms per ton of peroxide and maybe 30 kilograms of sodium hydroxide. Typical pulp yield 90 to 87%. And I just want to say that here that this process is normally not suitable for non-wood fibers, and then we have to go more into semi-chemical pulping to process those raw materials. So why should we use board grades or CTMP in board grades? And this is actually what Vaggeryd is doing, but they have produced CTMP from softwoods. They produce a mechanical pulp with sufficient strength properties and a very good bulk. And that is of course what you're looking for in many cases on board products. I've stolen this table from Stora Enso, and this is how they judge CTMP in comparison to a chemical pulp. That because of the bulk you get the stiffness for the end product, and especially if you use the CTMP in the middle layer. You might lose some printability, but that is not that critical when you have the CTMP in the middle layer. And of course the high yield gives you a significantly more efficient utilization of the raw material. You can see here a profile of a board, and if you follow the green black here, this is the density profile of the board, where you can see you have a lower density in the middle, which means a higher bulk, which means lower grammage to a given stiffness. So this is how simple CTMP is, a CTMP plant. You can see our refiners here in the middle. You need chips, electricity, water and chemicals, and you produce CTMP, steam, and you get some effluent. And here are some typical figures. You have a rather high yield, so you need 1.1 ton of chips to produce 1 ton of pulp. You need electricity, and the demand for electricity for refining here depends on the raw material and the end product. And I'm coming back to that. You need, of course, water in the system. The amount of water depends on the system solution and how you perform washing and so forth. And here are the bleaching chemicals for the chemicals for bleaching. And bleaching and impregnation, I would say. Since you have pressurized refining, you produce pressurized steam. And you get an effluent here, depending on how you close your system and how much water you use. And this effluent will contain then an amount of COD corresponding to the yield loss. And those are some typical figures. And this is a typical hardwood CTMP system. It's pretty similar to what was shown from Vaggeryd, actually. We have a chips washing part here. We have impregnation part with Prex impregnation. We compress the chips and it expands in the impregnation solution. In this case, in 2 stages. That is what we recommend for hardwoods with high density like eucalyptus. We need some retention time before the pressurized refining. And in this case, we go on with the 2-stage bleach plant, washing after bleaching, low consistency refining. We have a screen room with a reject refiner, and then washing at the end of the system. Typically, the production of a line like this can vary from slightly over 200 to over 700 tons per day. We apply chemicals then in the chip impregnation here to the chips, and the active chemical, as I said, is the sodium hydroxide. And to do the bleaching, we also need sodium hydroxide to activate the peroxide. So we are adding alkali in 2 positions, and both will affect the pulp properties, which I'm coming to. And then, of course, how you affect also the pulp properties depending on how much refining you are doing here. And this is a diagram showing the pulp yield. It's the estimated pulp yield based on how much COD we dissolve versus the total sodium hydroxide charge in chip impregnation and in pulp bleaching. Then you can see it's a rather good correlation here between the addition of alkali and the loss in pulp yield, independent of if you apply the alkali in chip impregnation, which is, if you start here with the blue, it's unbleached pulp, and then you bleach it up to 80 and 82 in brightness. You follow this line. If you apply 30 kilos in chip impregnation, you end up here at the low yield, and then you bleach this pulp, and then of course you will end up at an even lower yield. So we can correlate very much to pulp yield here. This is a little complicated diagram, but in the bottom here I put chemical energy, and if you say 100% chemical energy, that is what I call chemical pulp. We use very little refining and almost only chemistry to produce this pulp. In the other end, we have those purely mechanical pulps where we only use refining energy. And then without any chemicals, we get a very high yield. And here is a typical TMP. And then if we start to apply chemicals here, we have the CTMP. And I'm trying to indicate here that we have a rather big operating window for CTMP depending on how much chemicals we use. So the CTMP can actually be tailor-made for specific end use. Then between the TMP and CTMP and chemical pulp, we have the semi-chemical pulps, but I will not speak about those today. So the more chemicals we apply here, the more better potential we will have to develop strength properties. And as we do that, we will lose bulk or get a higher density, and we will also lose opacity or light scattering. So that is also important here when we optimize the CTMP, because if we use more chemicals, we will develop the strength properties and we will lose bulk. So it's a question of optimization here and compromising. And also, the more chemicals we use in the CTMP, the less energy we will need in refining. So this is a quite delicate optimization to do in each CTMP case. So the conclusion here is that the lower the pulp yield, the lower the energy consumption when we talk about hardwoods, and the lower the bulk and the higher the strength properties. So it's normally or consequently not a problem to reduce the energy consumption for hardwood CTMP. It's just to consume more sodium hydroxide in chip impregnation. So the question is normally wrong if you ask what is the energy consumption for this raw material. It depends what is your target end product. And for instance, what is your bulk target? So that was some basics. Now some words about raw materials. And what we see, because we work with CTMP globally, and especially amongst hardwoods, there is a huge variation in the different species and also within specific species. Here to the left we have an aspen, which is a poplar, which is quite porous and have a rather low density. And then extreme to the right is a eucalyptus, typically from Australia, with a density of about 600. And you can see that this dense hardwood is rather difficult to impregnate with chemicals, of course, because you see the distance here between the vessel elements in the wood. And you have to get the chemicals in evenly distributed in the chips. So because of this, each raw material has its own operating window, or in this case I call it a bulk banana, because it's a very significant, distinct relationship between tensile index in this case and bulk. It could also be Scott bond or some other strength property here. But if we take down this yellow one, which is for this Eucalyptus globulus, you can see that whatever we do in the process, if we bleach, if we refine, if we use chemicals, we follow this yellow relationship. So if we have set a final bulk target for this raw material, we will end up with a given strength property. And then we can also see ranking here between different raw materials. And at the end, at the bottom, you can see here the European aspen that we have here in Sweden. We have a significantly lower bulk at a given strength compared to, for instance, this or all the eucalyptus species. You can also see the red one here, which is acacia. It does not have as good potential in this context compared to eucalyptus, but it's better than the aspen. So when we do optimization here of a specific raw material, we follow this line. And normally the issue is to reach a high bulk with as low production cost as possible. Here's another aspect, and that is the bleachability. Because the problem here is if the raw material is difficult to bleach, like the green one here, for instance, we have peroxide consumption in bleaching versus brightness. And this is a terrible Chinese eucalyptus, which could only be bleached to 70 with quite a high peroxide charge. To reach this brightness, we of course need a lot of chemicals, and that means that we will destroy the bulk. So this will be a very strong pulp, and the potential for this raw material will not be high bulk pulp. Compared to this one, this eucalyptus, which was very easy to bleach, we could bleach it to over 85 quite easily in brightness. And of course, since it's easy to bleach, we don't need that much chemicals, peroxide and alkali, and therefore we can also here produce a very bulky pulp if we want to. So each specific hardwood has a specific operating window when it comes to bulk versus strength properties, and also when we look at the bleaching potential. So to optimizing the CTMP process, which is then the production cost versus pulp properties, we have to do a lot of compromises. We have to look at this relation between bulk and strength properties. We have to look at the bleaching potential versus bulk, the yield loss, the consumption of chemicals, and the specific energy in refining. So now we are in India, and if you look at the forecast for India, it looks very promising. The consumption of board and paper will increase dramatically, and the main growth will be in the board grades. And what is interesting for CTMP then is liquid packaging board and folding box board for different end uses. And that's where we come in now. And how will India solve this? And when we look at what India is planning today is huge investments in new plantations. And plantation wood is excellent for CTMP. Then we get a constant raw material, and we have all possibilities to optimize the process for a specific end use. And today there are no mechanical pulp mills or CTMP mills in India, what I know. So my proposal is that you should actually consider investing in CTMP instead of chemical pulp. Sorry, Eva. Here are some typical properties of eucalyptus and acacia CTMP, showing typical freeness levels, typical brightness levels, and then what you get regarding tensile index and bulk as an example. And you can see that it's possible to vary the bulk from slightly over 2, which still is much higher than for a chemical pulp, which is around 1.5 maybe. And we can produce a significantly higher bulk pulps. It's possible actually to produce a eucalyptus CTMP of a bulk of 4 as well. But then you have to accept, for instance, a tensile index of maybe 10 only. Yeah, so that is just one example what we can get here. So then my conclusions. CTMP is a well-proven alternative for board grades. We have very many installations globally. The high yield gives a significantly better utilization of the raw material, and the higher bulk, if you especially compare to hardwood kraft, can give you a reduced furnish cost for boards. And this is valid also for printing and writing qualities, of course. And there you also get this opacity or light scattering improved. So please, if you have any questions, please contact us, because it was Metso developing CTMP, and we are the market leader in this area. Thank you very much, and you are welcome to ask any questions. Thank you.
Thank you, Mr. Thomas, for the wonderful presentation. Now I would request everybody for questions, please. Whatever questions you have, you may ask through question window, and Mr. Thomas would love to answer that. If anybody has any questions, kindly ask. A question from Mr. Chiranjit Pathak. Is CTMP applicable to OCC recycling pulping?
Basically not. I think I didn't speak about semi-chemical pulping here, but you can have about the same process solution, but you aim for a yield of 82 to 78 and produce, for instance, an SSE of a hardwood. Then it's excellent, of course, for fluting qualities. But then you use a little different chemistry. You use carbonate and sodium hydroxide as a cooking chemical. And you need a higher cooking temperature, of course.
So if there are no other questions, actually there is one question which I left, and it is for Mr. Otto. I'm giving the speaking right to Mr. Otto if he can answer this question. Mr. Otto, can you hear us?
Yes, I can.
There was a question from Mr. Murthy. Would you please elaborate a little on use of krill?
Well, krill, that is fine material created on the surface of the fibers. It's very important for the bonding properties of the fibers. And the only way to really analyze the krill content of the fibers is using the techniques used in the pulp analyzer, because the krill, they are so small that you can't see them with camera technology. But it's a small part of the total fiber mass, but it's very important for the fiber bonding properties of the pulp. Hello?
Question for Mr. Otto.
Yes.
Any work being done with pulp-I for bagasse pulping?
Pardon? Any work done with bagasse?
Yeah.
With well, there's been a project at the Invensia using where bagasse has been studied. And I think it was part of the presentation at the PaperTech conference in June. Some results were presented.
There is a question for Ms. Eva. I'm giving a speaking right to Ms. Eva. Eva, can you hear us, Ms. Eva?
Yes.
Hello. Yeah. Ma'am, there is a question for you. What are the typical energy cost comparison in case of filter based and press based system in kilowatt hours per ton?
Hold on.
I'll repeat the question. What are the typical energy cost comparison in case of filter-based and press-based systems in kilowatt hours per ton?
I'll hold on. I have to check so I'm not saying anything wrong here. I don't have it that figure really. We had made the for just the filter and the press stage comparison. What I have then the installed power for these two different cases was for the filter 516 and 443 for the press. So it's less. 1/5 less, I would say, for the press. But I don't have for a whole fiber line. I can tell you out of my head. Sorry. Hello.
Thank you for the answer, Siva.
I can find out that figure and send it to this person who asked that question if I get these details, so I can send it to him.
No problem. You can give it to Mr. Matthias. Matthias Dots. He will forward it to me. I can forward it to the concerned person.
Yeah.
That can be done.
Okay. Yeah.
And there is another question. It is from Mr. Matthias Drots. Are there any difference in fiber properties between using presses or not?
No, not what we have, not what we have seen. It's no difference at the final end.
Any other questions from anybody? For pulp pipe from Dr. Sundar Raman. Pulp pipe, can you elaborate recent advances made with extract type?
Well, besides being used for these applications in Vaggeryd to predict pulp strength properties online, it is used in a number of other mills for similar purposes to control applications. We have mills that are using it for control applications, and it's used for monitoring also. Besides monitoring pulp stability, it's also used for monitoring the final pulp quality. It's used for monitoring the stability of a paper machine in the same way. There you also just need one trend. It's used in stock preparation area, and and it's used also. Extract is also used as a general analytical tool in many mills. You saw a number of mills that are on one of my slides that are using it for online applications. Both use it based on fiber data from PulpEye, and in some cases also fiber data from PulpEye and process data from the mill. Extracti has been around for about 20 years. It's been used in the pulp and paper industry for that long. It started out as an in-house software in the Modo company, but it's now commercially available outside the Modo company. Hope that gives you some ideas of the usability of Extracti.
Any other question from any of the participant? If there are no other questions, we would like to close this webinar. I hope all the people have enjoyed the presentations. They have learned a lot, and I would from Inventia, IVL, IPMA, and CI Godrej GBC, and also from SIDA, Swedish International Development Agency. We would like to thank everybody for the participation, and also to all the presenters who have given us a wonderful presentation. So thanks a lot. I would like to tell you that all these presentations we would be sharing with all the presenters, with all the participants, and you will be getting a copy of the presentation, a copy of the webinar also through mail. Thanks a lot. Have a wonderful day ahead. Thank you.
Thank you very much.
Thank you.